This is Algebra 2 with trig. This is 4.10. We're writing equations. This first equation that we're going to be working with, we're going to look at vertex form. We know that we need to use vertex form for this equation, for this graph, to write the equation of this graph, because it has information about its vertex. It also has an additional point on the graph. So using the vertex and using the additional point, we should be able to calculate what the equation would be to go through both of those points. Here are the notes on how to do that. We substitute the value of the vertex for the h and the k. We're going to substitute the values of the other point in for the x and the y. Now we have the h and k, the x and y covered. What we don't have yet is the a value. So we're going to solve for our missing a value. Once you figure out your a value, you're going to plug all the points back in, and when you write your equation, you want to be sure to use the x and the y as variables. You don't want to plug numbers into those. We only use numbers for those when we're solving for a. So let's try that with this parabola. We see here that we have a vertex, so that those coordinates should be your x. Those coordinates should be your h and your k. The other point, it could have been any point. It happens to be on the y-axis. Any point along the curve could be highlighted, and that's going to be our x and our y. So we're going to start out with vertex form, because they show us the vertex. We'll plug in our numbers. The y is 5, the x is -2, the h is -2. Let's see, the x is 0. Here's your x, it's x comma y, and the x is 0, the y is 5, the h is -2, the k value is -3. So to start grouping this together, a negative times a -2, it gives us a +2 squared. Positive and a negative make a -3. 2 squared is 4. 4 times a is 4a. Some people are making a mistake by saying 4 minus 3, but that's 4a minus 3. Those are unlike terms. So now we can divide by 4 and we would get 2. So our a value has to be 2. If you look over at your graph, a typical parent function would be when x is 1, y is 1, because you square the 1. 1 times 1 is 1. When x is 2, y is 2 times 2, which is 4. But if you notice here, we're going up 2 of them. Instead of 1, we're going up 2. Instead of going up 4, we're going up 8. We're going up twice as much. So that's where the 2 comes into play. Y equals 2 x. 2 negatives make a positive, so it's a +2 squared minus 3. Our vertex is -2, so in our equation it looks like a positive. The y value is -3, so in our equation it's -3. Another form that we could do this with is called intercept form, and that's y equals a, x minus h, x minus p, x minus q. Looking at our graph here, we notice we don't have a vertex this time. That's why we're not using vertex form. We don't have our h and the k because we don't know the vertex. We have both the x-intercepts and we have this other random point. So we're going to substitute the values of the intercepts, which are P's and Q's. We're going to substitute the value for the other point, which is X and Y. And we're going to solve for the missing variable. After we plug everything in, it's the A, which we don't have any number for. So we're going to solve for A. When you write your own equation, you need to be sure to remember to use an X and a Y as variables. Don't plug numbers in for those for your final equation. So we notice that we don't have a vertex, so we're not going to use vertex form. We're going to use intercept form. We're going to plug in our values for X and Y. Here would be our P value for our x-intercept and our Q value. So the Y is -4. The X is -2. The P, the formula says minus, the P value is -3. The X is still -2. Formula is minus. The Q value is the 2. Now it wouldn't matter which one of these you call P and which one of these you call Q, but because they are the intercepts, they have to be P or Q. -2, +3. -2 minus 2 more gives us a -4. -4 times 1, and then we divide, so A is going to equal 1. So our equation is going to be Y equals 1 for your A. We typically don't write that. X plus 3, because it's minus and negative. Minus and negative means plus. And X minus 2. Remember, what's inside the parentheses is always opposite of what it might look like. Looking at the picture, this says X plus 3 for your equation, but it goes 3 to the left. This is X minus 2, but it goes 2 to the right. We're now looking at the same type of question again, but without the graph, we're just given points. The points are the x-intercepts and another random point on the graph. So by the information that they give us, they know that we need to use intercept form. So our intercepts, this is going to be our P, this would be the Q, this would be our X and the Y, because it's a random point on the graph. So our Y value is -4, the X values -1, minus, the P value is -2, the X again is -1, minus, and the Q value is 1. -1, a negative and a negative make a positive. -1 and -1 make -2. And when you divide by your -2, you're going to get a +2. So your final equation is going to be 2 times X plus 2, X minus 1. Remember, it's always going to be opposite of what the intercept looks like. it's at negative 2, so in the equation it actually looks like an x plus 2. Positive 1 is going to look like x minus 1. For this next question, they give us the vertex, so we know that that is your h and k. They give us a point on the graph, which is your x and your y. So that's our basic equation for vertex form, a standard equation in vertex form. So your y value is 4. We don't know the a. The x value is going to be 0. Your h is 2. So the formula says minus h. So it's a minus 2. And your k value is a positive 1. When you square a negative 2, you get positive 4. A lot of people make a mistake here and they say 4 plus 1 is 5, but you can't do that. This isn't really 4. This is 4 times a. So it's really 4a plus 1. So you have to subtract the 1. And then divide by the 4, and a equals 3/4. So your final equation is going to be 3/4 x minus 2 squared plus 1. For the second side, we're looking at another example. Here we have 3 different points. These points, we're not told that any are the vertices. Looking at the values, none of them are x-intercepts. That's when the y value is 0. We don't have any y value 0, so we don't have any intercepts. These are just 3 points. And we're looking for an equation that's going to go through those. We're going to use a new method. We're going to use matrices to solve this. So what we like to do is take the 2 and the negative 6, the 0 and the 6, 2 and the 2. Those are your points that you're given at the beginning of the problem. We're going to take those points and plug them into our standard form of a quadratic equation. So we're going to plug in our y value, which is negative 6. Our a is what we don't know. The x is negative 2 squared. Our b value we don't know. Our x value is negative 2. And our c value we don't know. We're going to repeat that with our other point. Y is 6. X is 0. And we don't know the c value. You might be able to predict that now. 0, 0, c equals 6. Our y value is 2. Our x value is 2 also, so we're going to square that 2. The x also goes for your bx plus c. So now we've plugged in our values of x or y into our equation. As we simplify this, we have our negative 6. When you square negative 2, you get a positive 4. So we could call this positive 4a. Negative 2 times b gives you negative 2b. And c is just at the end. 6, we have 0a minus 0b, or you can call it plus because that's the way the formula is. It's just 0 plus c. 2, when you square the 2, we get 4. So 4 times a is 4a. 2 times b is 2b. and then our C value. So now we're looking at three linear equations. So we're going to use this to obtain a system of three linear equations. So since we have three variables, we need to have three equations to solve for it. We could use substitution, we could use elimination. What we're going to end up using is matrices. The first thing we're going to do with the matrices is write a matrix equation. So we know that an equation has an equal sign in it. An equation has variables in it. So the variables that we're solving for is A, B, and C. And an equation's got to have some numbers in it. So the numbers we're going to use on the left side are going to be the coefficients. The 4, the -2, and the 1, the 0, 0, and the 1, the 4, the 2, and the 1. We're going to take the coefficients from our equation up here and put them into our matrix. So we have 4, -2, and 1, because in our first equation we had a 4, a -2, and a 1. 0, 0, and 1, 4, 2, and 1. Then what our equation is going to equal, because this is a matrix equation, what our equation is going to equal is what our equations up here equaled. -6, 6, and 2. So this is our matrix equation. It doesn't mean too much, except it's looking at what the matrices are going to look like when we plug them into our graphing calculator. So we're going to take our graphing calculator. Matrix is underneath our inverse key, which is kitty corner to the 7 above the x squared. So second matrix should give you a screen with a whole bunch of letters down one side. It says name, math, and edit. Well, we want to edit what A is. So we're going to go over to edit. And then we're going to say I want to edit matrix A. It gives you some numbers at the top. Those are the dimensions of our matrix. So because we have 3 rows and 3 columns, we're going to call this a 3 by 3. So you type a 3, you hit enter, you type a 3, and you hit enter. So that gives us also 3 rows and 3 columns. We're going to type in the numbers we have in our matrix here. So 4, -2, 1, 0, 0, and 1, 4, 2, and 1. So we have all our numbers in that first matrix. We'll call that matrix A. Then we'll go back to matrix. So you hit second matrix. We need to go over to edit first, because you want to edit matrix B. Now we're going to type in the values for our answer matrix. So it's 3 rows, 1 column. And when you type that in, you'll see that they give us 3 numbers above each other. So we have -6, 6, and 2. We now need to get out of the matrices completely. But then we're going to have to get back in. We're going to hit second quit, that second mode. Quit is written above the mode. So that gets out of the matrices completely. Now let me show you something else. If we were going to solve 2x equals 8, we could either divide or we could multiply by what's called the inverse. to multiply by the inverse of 2 is 1/2. And we're going to also multiply that to the other side. So the 2's cross out and x equals 4. Well, we're going to do the same thing with our matrices. You can't divide by a matrix, but you can multiply by its inverse. When you multiply the left side by its inverse, essentially it crosses out and it becomes a value of 1. When you multiply the second side by its inverse, you're left with A, B, and C equaling whatever that product is. So when you type it into your calculator, you want to be sure to use A inverse times B. The A inverse has to come first. The order does matter with matrices. So with our calculator, we're going to go back to matrix, so second matrix. This time we don't need to go into edit, we're just going to be here with names. So we're going to hit enter, and the A matrix is going to come off to the home screen. We want to do A inverse. The inverse key is kitty corner above the 7. That's A inverse times matrix B. To get matrix B, we have to go back to matrix, which is second inverse. We go down to the B because we want matrix B, and we hit enter. That puts in A inverse times B. By hitting enter, we get these three numbers, -2, 2, and 6. Those numbers are standing for A equals -2, B equals 2, and C equals 6. So when you write your equation, we get -2x squared plus 2x plus 6. That's the standard form equation of a quadratic function that goes through the original 3 points. If you work with this and try to do the inverse, multiply the 2 out, if it doesn't work, you get an error message in your calculator. Be sure you type in the numbers correctly. But what that means, perhaps, is that these apparently lines, or supposedly lines, they don't cross. So it's possible you'll get an error, meaning that given those values, you can't come up with an equation that hits them. That is possible. Usually something can be determined. Okay, our last example down here. We're going to use a graphing calculator to come up with an equation. It's called quadratic regression. Our answer is going to be again in standard form, so it's going to look like ax squared plus bx plus c. We could take 3 of these points and do it the same way we just did with matrices, but we would only be using 3 points. Using our calculator and lists, we can use as many points as they want to give us. Then we can find the best quadratic equation that goes through, or close to at least, all of those points. So we're going to start with stat. Go to edit. You've done this before. 0, 2, 4, 6, and 8. Those are the x values on your table. Then we go over to list number 2, 3, 28, 40, then back down to 37, and back down to 26. So if you think about what's happening here, At 0, you'll be at 3. At 2, you'll be at 28. At 4, you'll be at 40. At 6, you'll be down a little bit at 37. And then at 8, you'll be down even lower at 26. So it slowly keeps coming down. So we have our points plugged into our list. Now we're going to hit Now we're going to go back to Stat. We'll go over to Calc. We'll come down to Quadratic Regression. Quadreg stands for Quadratic Regression. Go down there, hit Enter. Your screen might look like this, or it might just say Quadreg written at the top. The question is your information in list 1 and in list 2? If it is, you can scroll down to Calculate or just hit Enter. And now we know what our A value is, we know what our B value is, we know what our C value is. So we're working in the format of ax squared plus bx plus c. So our equation for our A is negative 1.55 x squared plus 15.18 x plus 3.37. That's the quadratic equation that would best fit all of these points.